My name is Johan Borgström. I have a background in design. I've studied industrial design. And it was at design school I discovered animation and design visualization. So that's what I've been doing ever since then. So we're going to start with looking at a few of the samples of the work I've done. Thank you. Thank you so much. So let's start with an overview, super simplified overview of the design process. You have some sort of input data, problem you need to solve. You can do a couple of sketches. You might build prototypes, and then you will evaluate what works, and then you hopefully have a good output. And you can use the same, like I use it anyways, mental model. When you work in Houdini, you have some sort of input. It can be input you generated yourself, but it can also be CAD data, it can be textures, and so on. And you want to process them in some way to get a result that you want. And since Houdini is a node-based system, procedural, you can just branch out, try something. If it doesn't work, just delete it. You will never destroy the input data. And then if you find something that works, you can select those nodes and you can make an HDA out of it, Houdini Digital Asset, which is a really convenient way to reuse. If you come up with a really good solution, you can reuse it later or share it with your colleagues and so on. So that's HDA. And then just briefly wanted to mention the copy to points node. I use it all the time. It's super powerful. It's quite simple in concept. You have a set of points, and these points can have attributes like color, position, rotation, and so on, and also name. And if the copy to points node, you can set it up so if it finds a name on the geometry, it will use that piece. And then you can also transfer color, position, or rotation, and so on. So I'm going to use that a lot in this project. The project I'm going to present is basically a learning project for myself. I wanted to explore workflows to use in the automotive visualization, like to quickly build a terrain, do car animations, and then camera work, and then translate that to Unreal, and then back and forth between Unreal, Houdini, and DaVinci Resolve. So I wanted to explore ways to work. Yes, so this presentation, we're going to do a quick overview of the environment modeling. Look a little bit on the car model setup, animation, and then Vertex Animation Textures. And what that is, I'm going to go into a little bit later, and then also look at the camera workflow. So let's first look at the video of the project. Yeah. Thank you. So let's look at the modeling. It's super simple. You have a NURBS curve, starting with a NURBS curve. And then I created an HDA that will just create road geometry and add a little visual interest to the side of the road, so make it like a little noisy there. And then I created a node that will add vertex colors. And these vertex colors is just RGB and alpha values that you then later can use in Unreal to blend different textures together to make, give more visual interest. And it's also a good idea to sometimes separate HDAs. You have one HDA that will create the road and another that creates the vertex colors. Then you can reuse them, so they are separate from one another. The terrain is a simple height field. Houdini has really nice height field nodes. Then I added some noise to it. And then I created an HDA that will blend this road geometry into the landscape, and you can select like the fall off and so on. And here's over in Unreal is the road. And I added some detail, like decals in Unreal to give a little bit more visual interest. There's some static meshes, and there's an HRI backdrop. This is the car model setup, because I found this model that I really looked super fun to animate. But it was a Collada file, so when I imported that into Houdini, it was like, it was that. And I know I wanted to use the copy to points node that I showed earlier, because that makes it really easy to animate the points and the geometry will follow. So I needed a way to convert this into like copy to points compatible setup instead. And it would be too much manual work to do it, yeah. So I wrote a Python script that will do it. And it looks at, okay, what kind of data do we have? We have like position and rotation of all these geometries. So we know where the points should be. And then if we go into one of these nodes, we're going to find a file that's pointing to the mesh on disk. And then we have information about the shader. And if you look at the shader, we have the shader name, and we can also have like the color value. And some of the geometries had textures, so I needed a way to be able to also store the textures and create a texture atlas out of that. Because in Unreal, we're only using one material. So we needed a way to get all these textures to be applied in one material, not different materials. So I wrote the script that we just go through the Collada file and gather all this information we looked at, and then outputting like the unique meshes as one geometry. And then it will output the points. And then we can use, here's the same model, but it's using the copy to points instead. So I'm going to show a video of how the script works. So if you select the Collada file, and then it will set up, it will ask you for an output directory, and then you just save. You save the output, and it will prompt you, if you have this material file that looks, if you want the texture information, you can use that. If you don't have it, it's okay. And then it will create this point cloud, and then it will also save the unique meshes. And here's just a copy to points, basically the same. It copies the unique meshes onto the points. And what is cool now is like, if we want to animate the points, which we're going to do now with a node called exploded view, we can just explode the points. We set some attributes first. And then we can just set the uniform scale. So this is basically the effect of the points expanding and shrinking. So that's quite nice to be able to just animate the points. Then on the car animation, I wanted some way of creating a, not physically accurate, but something that looks okay. So I created an HDA that will like procedurally generate some points that we can use as a car rig. So it takes a curve as an input, and it takes the ground as well. So it will follow this curve, and it will collide with the ground to generate some points we can use. And then I wrote the Python script to export this point information, the position, the name, and the orientation, basically the rotation of the points, so we can take them into Unreal. And I exported a JSON file out of that. And over in Unreal side, we can load this JSON file, and it will apply to the actor selected in the outliner. It will generate animation for us, animation keyframes, which is quite quick. You could send it directly from Houdini to Unreal, but I took this intermediate step just to save it as a file. So if you look at the car rig, yeah, so you can see that it's basically following the curve, and you can see this this visualizer is showing the wheels are rotating. And we just drag and drop the data we want to export, and we save it as a JSON file. And then over in Unreal, we can select the root actor, and the script will look for child actors named a specific way, so matching the names in the JSON file, and it will apply the animation to those points. Here we select that. And you see that middle actor as well, that's the body. We're not using it yet, but we will add the body of the car to that actor later on. So let's look at how to animate the points when they are exploding. So we have this is the starting point, like the neutral point. And then I use this exploded view node to explode the points in sideways, and then to explode the points back and forth. And then I wanted to be able to animate between these different like states or like shapes. So I wanted to use a procedural mask just to drive that animation to get it, yeah. And this is, I created an HDA that is based on the work of Mark Fancher. He has some really good tutorials, and especially look at the MFX modules for Houdini. It's really, really good. And then we use this mask to drive this animation. And we do the same for back and forth, or front and back. And what we do here is we want to have this offset going from 0 to the exploded state, so that we can, in this node setup, we add this animation to the neutral positions, and then we add this offset. So we could be done here with animation of the points, but I wanted to add a little bit of noise as the points were traveling in the world. So to do this, we can get this transform that we got, like the body position of the car rig we looked at. We can get the position, the orientation from that, and with that we can affect the points so they will travel in the world. And when the points are traveling in the world, we can add some noise. And this noise can be based on like where the points are in the world. So we get this little jiggle as the car moves along. And now we have the jiggling points driving in the world. But since we're going to use the piece animation, we want it to be centered around the origo. So what we do is we can subtract the animation of the car rig. So we just invert that, and then we are left with the animation around origo instead. So I'm going to show a video so it explains that a little bit clearer, hopefully. Yeah, so here we see the front and back exploded view. And here's the animated mask. And here's the offset, so we're going from 0 to full. And then we can add this offset to the original position. And then it will look like, yeah, as we... This is basically the animation of the Lego pieces. But now they are around origo, and we want to travel in the world. So we can do that as we transform it with a car rig. So now they will be driving in the world with this animation as well. And then we added this slight little noise. I don't know if you see it, but it's a slight jiggle. And then we can basically remove this animation as it travels in the world. So then we will have these points in origo. And this animation is what we're going to use to drive the Lego pieces. And here is the animation with the copy the points node, with the animated points there. So let's look at, because now we have the animation of the pieces, and these are a lot of points. So to animate them like quickly, like in real time in Unreal, one good way is to use Vertex Animation Textures, and that is a way to store animation as a texture. So we will write where each point is at a specific frame to a texture, which we then can read in the material in Unreal. And Junichiro Horikawa has a really good tutorial where he goes through like sending attributes to Unreal from Houdini. So I created a little video just to visualize the concept of Vertex Animation Textures. So what you see now is the texture in the background, and this orange line is the currently sampled point. And then I drew a line from the pixel to which point, like Lego piece, is being animated. So just to visualize. And Side Effects Labs has really good Vertex Animation Texture exporters built in. But sometimes I like to reinvent the wheel just to learn things. Quite good. Takes a long time, but you learn a lot. And I also wanted to make a Vertex Animation exporter that is like mimics the copy the points node, how that works. So you take a set of unique meshes and a set of points, and we'll output textures and a mesh. So if you look at the point side of this, now we are inside the HDA. So what we need to do is, these are the animated points. So we add a time shift on the first frame, so we keep that point as a reference. It will not move, it will be our first frame. And then we store the pivot of the position. So we want to use the pivot in Unreal later on when we calculate if things are scaled and rotated, so we need a pivot. And one way to get a pivot in Unreal is to store it as a custom UV channels on the mesh. And then another thing is to be able to sample, to know which pixel to sample, we need the point number. And the point number is an integer, and we need to save it as a color value of the mesh. So we do this operation, and I got that operation from Unidico. And this is just a way to write a number to a vector, vertex color. And here we set up using it's a thing in Houdini, like a for loop. So what this for loop does, it's for each frame in animation, it takes all the points, animated points, and it will create a grid. And we will save the texture, like the attributes, like where the point is and how it's rotated and so on, to this point. And this grid of points is basically the texture. And then we can take this grid of points and we can create a texture from these points. So these points are basically the texture. We just need to convert it to a texture that we can save to disk. Yes, here just how to save the pixels from the points. And on the mesh side, because we had two inputs to this node, we have the points, animated points, and we have the mesh. And this is the same unique mesh like that we've seen before. And what we do now is we want to save. We use the copy the points node to create this car mesh, and we transfer this pivot information, and we transfer the vertex color. That's why it looks red, because the red is basically the point number, but as a color instead. It's a little bit weird, but yeah, that's how it works. And then we export the mesh. And it can be a good thing. What I'm doing here is just saving, giving the mesh a name, so we know maybe the start frame, end frame, and so on. So we can easily see this mesh goes to this texture. So just a way to keep track of things. So now we have the mesh and we have the Vertex Animation Texture. So we could take this mesh into Unreal and we could animate it using this texture. But we are missing the textures because we have one material. One material can only sample like a texture. So we need a way to be able to sample multiple textures in an efficient way. So then I created this HDA that will look at the textures that we saved in the previous step, and it will create a texture atlas. So it basically will place every texture in a grid, and then set up UVs so we can sample it in one sample node in Unreal. So this is also inside the node, and we have some of the points had solid colors, and some of the points had textures. So here we're splitting that. So for the solid colors, we don't need that much texture space. We just need a little texture because it's just one solid color. On the texture side, we need more texture, like resolution. So that's why we split it here. And this is the solid color points. We can be a quite small texture, could like be 128. It can basically super small. And then this is the textured side. So these points indicates how many textures there is. And we will use this point later on to create this texture atlas, which we're going to look at. So here are the UVs. So top is in the top left corner is the solid colors, and beneath is the UVs for the geometries that had textures. And this is inside a compositing network. So I'm using a node called stamp point, which is basically a copy to points, but in 2D. So we can generate these tiles of colors. And that is placed in the top left corner on the image on the right there. And the rest of them, I use a node called contact sheet, I think it's called, yeah. Just to lay out all the textures in a grid. So this is the Vertex export node. So we select where to save the textures. We can select the frame range. We can select which attributes we want to export. We could export color, emissive, and so on. And then we export. And this is the, yeah, I wrote also, just to visualize this Vertex animation, a node in Houdini that would read textures and then converting it back to animations, just to verify that the animation was working correctly. So this is the same animation, it's just using textures to drive the animation instead. And here is a visualization of like how it works. And this is the incoming, this is the mesh that comes out from the Vertex exporter. So the red mesh indicates that it's a point color, that's the point number. And then we have the points, and here we create this tile texture that I showed earlier. So we can just select an output directory. What we want to do is we want to export the mesh again, because what we've done, we saved this UV4, like how to sample this texture, like that. We need to add that to the mesh we exported, so that Unreal knows which texture, like how to sample the textures in Unreal later. And this is the texture atlas. So over on Unreal side, we just import the mesh and the textures. And then we add the car body as a child of the actor. Now we have the car driving along, but we don't have these pieces yet, the piece animation. So we create a material that can read these textures we created, and we assign that to the model. And then we animate a frame value, like which frame of this animation should we use. And now we have this animation driven by textures. If we want to, we can look a little bit on the material later. So here's a video of the import process. We drag in the car, and then we add it as a child to the node, to the body node. So now we have the car animated, the body, but we don't still have the piece animation to it. And this is the material. So what you want to assign is you take these textures, you export it, and then you just add it to the material. And then based on this frame value, it will sample the texture, and it knows where to position the vertex of the mesh. And then, because I like to script and I'm a bit lazy, I wrote a script that will generate this frame keyframe. Basically what it does, it sets a keyframe based on the start frame and end frame. And it just makes it a linear value. So it's like on frame 10, it will sample frame 10 and so on. So now we can drive the animation. Oh, sorry. Did not mean to do that. Yes, let's look on the camera workflow. Setting cameras on moving targets can take time. So I wanted a way to just quickly mock up 20 cameras quite fast. And then you generate a lot of cameras, and then in the edit in Unreal, you can select what works for you in your shot. So you have plenty to choose from. And then to get plenty of cameras, you don't want to waste a lot of time to creating these cameras. So it should be quite fast. These two nodes is taking an input. It can be any node, any input that has a transform. So this transform will be used to drive like the position of the camera. And then it also takes the ground input. So we don't want the camera to go beneath the ground. So this is just a simple way to make sure that you have some collision with the ground, so the camera will never go beneath the floor. And then, using the same script, basically, to export the camera animation as JSON, and then take it into Unreal. And in Unreal side, I wrote a script that will take this camera input, and it will set up a master sequence. So it will lay out all these camera tracks for you, and then you can do a rough edit. So let's make it quite fast just to get to the edit stage. You can also choose to include, like in the section there below, use anim sequence. You can specify which animation sequences you want to use as a subsequence, which can be good. And then when you find your edit in Unreal that's working for you, you can, sometimes you want that edit maybe over in DaVinci Resolve, or you want that edit over in Houdini again to do things. So I wrote the script. You can also export this edit as a JSON file. And then we take it into Houdini. And here, since we have the cameras in Houdini, and we know these edits, we know when each camera are used, we can use this script to automate, batch process out data from Houdini and send it to DaVinci Resolve and so on. And here's a video of the the camera rig. So yeah, it's just some basic transformation, and it will follow when the car is animated. And there's some more options. You can set it more manually, not just use a slider, but you can use it to freeform place it. And here's a simple overview, how to set the focus plane, which can be, the focus plane is tracking the aim, but you can also set it manually if you want to add an offset. And then you select the cameras and you export it, once again as a JSON file. And then over in Unreal, we can select where we want to save this master sequence. And then we can choose which folder that has the animation sequences we want to use. This is the car driving around and the Vertex animation. And then give it a name. And then we create, we add the sequences. And then we have our edit. So this is just a starting point. It lays out all the scripts in the timeline. So you can just quickly select which shots works for you and what doesn't, and then you can just find an edit that works. So this is basically the final edit. And when you're happy with that one, you can export it. So now we are over in Houdini again, imported that camera edit. And now you can click just the timeline, and it will set the cameras, and it will set the frame range as well. And this can be useful if you want to export lens flares, like a 2D position, if you want to export a 3D position or something from Houdini to whatever software. So it can be good to know that edit and which cameras are being used. And here we basically do a flipbook and then import that flipbook in DaVinci Resolve. Yes, that was it. Thank you.
Amazing, amazing. Love it. Questions for Johan? You're not allowed to ask. Just kidding.
Can you explain a bit more about your camera HDA setup? Do you set up static cameras and then your HDA animates them correctly? Is that how you get multiple 20 cameras? Is that how that worked?
The idea was you get a transform that can be whatever. It can be one little Lego piece. If you want to spin around that piece, that can be quite tricky to do. So now we have this, you can get this transformation of the Lego piece, and that will be the input for this first node, and it will generate the transform to drive the second node, which is basically the camera. And in that node, you have a script that will create a Houdini camera out in the object context. So it will link to that camera. So then you have multiple HDA nodes, and it will multiple cameras. So that's the way I set it up. Yeah.
Cool, thank you.
Yeah.
Anyone else? Don't be shy. This is all interactive. We're asking questions here. Open discussion. Got it.
Thank you for the talk. It was so interesting. Do you think about selling this script or the scripts as well?
No, in that case we do something. Oh, yeah. We can provide it if you.
Oh no.
Yeah.
Thanks.
The script is pretty rough right now, so I wouldn't send it out. But yeah, we can definitely. We can see what we do with this. Yeah.
Looks amazing. Thank you.
Cool.
Anyone else in favor of that?